In this video, we're going to be verifying inverse functions graphically. We're given two functions, y equals 2x minus 3 and y equals a half times x plus 3. We could graph those by hand, but what I'm going to do instead is I'm going to jump to Desmos. I'm going to have Desmos do the graphing work for me. I've already typed the two functions into the left side. Y equals 2x minus 3, let's turn that one on. Y equals a half times x plus 3, let's turn that one on. We can see the two lines intersect. We could find the point of intersection just by clicking on the graph, which is very nice. We can also easily find the x-intercepts, the y-intercepts of both lines. We could jump to the other line and you could see the y-intercept and the x-intercept. Desmos is a very helpful tool when we are learning about functions. So what I'm going to do is I'm going to graph the line y equals x also. So the reason I'm doing that is because if the two functions are inverses, then one line is a reflection of the other line across the line y equals x. Now, why is that true? Well, we learned in a previous video that the domain of one function is the range of the inverse function. And the range of the original function becomes the domain of the inverse function. So what was x is y on the inverse function, and what was y is x on the inverse function. So essentially, any point on the graph, let's just say 1, -2, I'm just making this point up. 1, -2, I don't know that it lies on either line. But 1, -2, if it is on one of the functions, then the point -2, 1 will lie on the other function. Okay, what was x and y is now y and x. And again, we're strictly talking about the values of x and y. Let's jump back to Desmos. Now, I've also made a table of values for points that are on y equals 2x minus 3. Let me turn that on. Okay, and you can see those points in this table show up in blue. Now, in this second table, notice I have taken x's and y's and I have swapped them around. So the point -1, -5 in the first table shows up as -5, -1 in the second table. The point 0, -3 shows up as -3, 0, and so on and so forth. So if these two functions are inverses of each other, then all the points in this second table should be on the other line, y equals a half times x plus 3. So let's turn that on and see if that's true. Okay, and sure enough, you could see every single one of those points lies on the line y equals a half times x plus 3. And I could just click on these points and you can see, well, let's start over here. -1, -5, you could see -5, -1 lies on that line also. We can go to the next point, 0, -3, and -3, 0 lies on the inverse function. And that is true all the way up. And notice that as we get up, these two lines intersect, and they intersect at the point 3, 3, and that point lies on all three of these lines. Y equals 2x minus 3, y equals a half times x plus 3, and the line y equals x. So when these two lines intersect, if a function intersects with its inverse function, they are going to intersect at the line y equals x. So as we get back here, what we have proven is that these two graphs are inverse functions by analyzing the graphs of either function. I'm going to throw in a caution note. Okay, in order for this to be true, you must check many points. So if they ask you, or if you are ever asked to verify that two inverse functions, or I should say, let me back up. If you were asked to verify inverse functions graphically, you must check many points in order to do so. And mathematically, this is a side note, this, in my opinion, is not enough in order to verify two functions are inverses of each other. However, it is a useful exercise to understand the relationship between a function and its inverse graphically.